All right, today's lesson is area of shaded regions. So we're going to be looking at figures where you're given a figure and you have to figure out the area of just the shaded region. So for example, in this triangle, this shaded area here is what we need to figure out. So when you're given figures like this, the best method is calculate the area of the entire figure and then subtract the area of the unshaded region. Some figures you'll see will be all shaded. In those cases, you can calculate the area of all the parts and then add them together. So let's start with this example. So we have a triangle and there's a square inside this triangle that we need to subtract out because we need to calculate the area of just the shaded part. So let's start by calculating the area of the entire figure. So it's a triangle, and our formula for triangle, so area of triangle is equal to 0.5 AB. Okay, so 0.5, altitude or height is 24, and our base is given to us as 12. So we can multiply this out, and we'll get the area of the triangle, which is 144 centimeters squared. So 0.5 times 24 times 12 gives me 144 centimeters squared. Next, I'm going to figure out the area of this square. So area of the square is equal to side squared. All right, so what do we know here about the side of the square? So we know from these dashed lines here, we know that, well, the total base of this triangle was 12 centimeters, and this side, this part and this part have the same measurement. So because the whole side is 12, that makes it that this has to be 6 and this has to be 6. So 6 centimeters and 6 centimeters gives me a total of 12. So that means the side of the square is 6 centimeters. All right, so 6 squared, which means 6 times 6, it gives me the area of the square as 36 centimeters squared. All right, so now we need to subtract out that area of the square to get the area of just the shaded region. So the total area, or the area of the shaded area shaded, is equal to 144 centimeters squared minus the 36 centimeters squared, which gives me 108 centimeters squared as the area of that shaded region. All right, so here is our next example, and what we have is a rectangle, and then inside the rectangle we have a circle, and we have to figure out the shaded area, which is all of this and all of this. So what we're going to do is figure out the area of the entire figure, which is the rectangle, and then we'll figure out the area of the circle, and then we'll subtract the circle from the rectangle. All right, so let's start with area of rectangle, which is equal to length times width. All right, so our area is going to be 6 times 4, which gives me 24 centimeters squared. So that's our area of the rectangle. Next, we have to figure out the area of the circle. All right, so notice here the length from here to here is 4 centimeters. That means the diameter of the circle is also 4 centimeters. All right, so the area of a circle, the formula is A equals pi r squared. So we need to figure out our radius. Well, we have our diameter. Our diameter is 4 centimeters. Our radius is half that. So our radius is equal to 4 centimeters divided by 2, which is 2 centimeters. All right, so our area then is equal to, I'm just going to put 3.14 for pi. Our radius is 2. It's 2 squared, which means 2 times 2. So area is equal to 3.14 times 2 times 2. And we get 12.56 centimeters squared. All right, so we've got our rectangle, we've got our circle, and now we have to do our area shaded region. I'm just going to call it area shaded like that. So we're going to take our 24 centimeters squared, which is the entire figure, the rectangle, and then we're going to subtract out the circle, which is 12.56 centimeters squared. And when you subtract those two, we get an answer of 11.44 centimeters squared as the area of the shaded region. So here's our next figure, and let's start by figuring out what all the different parts of this figure are. All right, so let's start. We know from here to here is 8 decimeters, and we know these two sides are equal. So because this is 8, this therefore has to be 4 decimeters, and this also will have to be 4 decimeters. All right, so the double dashed line. Here we have 3 decimeters from here to here, so therefore from here to here will also be 3 decimeters. So this will be 3 decimeters. All right, so we have 3 decimeters and 3 decimeters, which is 6 decimeters. So that will give us the diameter of our circle. So let's start with the area of the circle. So area of the circle, which is pi r squared. So we know that our diameter is 6 decimeters. Our radius is 3 decimeters. All right, so the area of the circle is going to be 3.14 times 3 squared, which is 3.14 times 3 times 3. So that gives me 28.26. Now, that is for a full circle. We only have half a circle, so you have to divide it by 2. All right, don't forget that step because it's half a circle. Divide that answer by 2, and that gives me the area of the circle as 14.13 decimeters squared. All right, so that is the area of the circle. Next, let's figure out the area of the 2 rectangles. So let's do area of rectangle 1. All right, so area is equal to length times width. So rectangle 1 would be this one here. I'm just going to show it like this, that I'm splitting it like this. So rectangle 1 would be a total of 6 decimeters multiplied by 4 decimeters. So area is equal to 6 times 4, which gives me 24 decimeters squared. So that's our second part. And then we have rectangle number 2, which is down here. So area of rectangle 2, area is equal to length times width. And in this case, then, it would be 4 times 3. Okay, 4 times 3. gives me 12 decimeters squared. All right, so we have the 3 parts figured out, and now we can add all 3 of those together. So area total would be equal to 14.13 plus 24 plus 12, which gives me a total area of 50.13 decimeters squared is the total area of that shaded region.